Alright, so in the last few years, we've seen great advancements in the field of AI, agentic applications, voice assistants, and LLMs in general are just keep getting better. But let's take a step back and talk about one particular voice assistant that is lagging behind in this AI race. Siri. So if you've been keeping track of AI news lately, be it LLMs or agentic applications, then you probably already know the current state of Siri. Is just bad. Check out this MKBHD video where Marquez explained the Apple AI crisis. And after watching this video, I wondered if we could replace Siri with our custom AI agent. I mean, we have these open source libraries and LLMs that we should be able to utilize to build our own custom agent. So in this video, we are going to make Sam, a Siri improvement, and just like Siri, we should be able to trigger Sam with Hey Sam. And the interesting part here is that Sam will be using the voice of Sam Altman. Don't believe me? Hey Sam.
Hey, how can I help you?
Can you tell me what are your latest reasoning models that you have launched?
As Sam Altman, I can tell you that OpenAI recently launched new AI reasoning models called O3 and O4 Mini. These models are designed to excel at solving complex math, coding, and scientific challenges, while also demonstrating strong visual perception and analysis. The O3 model, in particular, can think with images, meaning it can understand and analyze sketches, diagrams, and other visual inputs, even if they are low quality. We have also stress tested these models under our most rigorous safety program to date. Additionally, we plan to release an enhanced version called O3 Pro exclusively for ChatGPT Pro subscribers. These reasoning models may be the last standalone reasoning models before the arrival of GPT-5, which aims to unify traditional models with reasoning capabilities. If you want to know more or have other questions, feel free to ask.
Alright, let's move to the IDE and see how we can build this project. Awesome. So we have our project set up, and as you can see in front of us, I have named it as Smart Siri. And this is kind of structured in a plugin way. So you can see that we have this example folder right over here, and all of the plugin code, the platform interface, the method channel where we set up the communication between the Swift files and the Flutter files are over here. We'll talk about that. So first of all, let's see for our plugin what packages we are looking for. All right. All of the code is in my GitHub repo and description box below, so do check that out too. If you found the code helpful, make sure to drop a star as well because that really helps. All right. So inside our plugins, we don't have any package itself that we are importing, so that's good. Now let's go back to our lib folder, and as you can see that we have this Smart Siri, which we are going to utilize inside our main.dart. So let's open that up, main.dart, and here you can see that we are utilizing our Smart Siri plugin. We have basically a few functions that we are going to set. First of all, we have basically, okay, how many? 1, 2, 3, 4. Four functions that are helpful inside our client side, inside our main.dart file. So first is we are setting the on success. Whenever we receive any message from our app intent Swift file, so from our Swift we get any message, then we just simply call the set on success and we pass our message string to this background success callback, which is nothing but a future function, and it takes a parameter, and I've set it as dynamic because it can be either a string or in form of uint8 list, that is bytes. So to better understand this, let me go and show you the main.dart file, because in the init state, as you can see, first we initialize our Siri object, and here inside our init state we specify inside the on success we need to set this method which is actually getting the message, And inside here we have our logic setup that I will be talking about in a moment. But as you can see, if it is of uint8 list, meaning that on success, once all of the processing is done, once our agent AI is ran, then on success what we need to do. So here I'm simply getting the bytes of the audio and playing that using our player object. So I'm using this simple audio package inside our example project. So you can see inside the spec YAML of our example project, I've added this simple audio plugin. So we are simply using that to play our bytes that we are getting from our API response that we'll talk about. But that's about it regarding the first function on success. And let's see the stream. So this is interesting because whenever we get any message back, we are going to listen to this stream. So this is also called inside the init state. So we are setting the stream and we are listening to it, and we have this method on query. So whatever task or whatever message that we get from our app intents from the Swift side, that will be passed on to this on query method, and that task, that message will receive here inside our Dart. So I have simply integrated one API here that we will talk about towards the end of this video, where all of the basic agentic workflow is happening. Idea is that inside this on query method, since it is of asynchronous, we can build a BYOK application, that is build your own key app, or our complete agentic workflow directly in Flutter, or you can build it in Python or any other language or framework and utilize that via API that I am doing in this video. So I'm just calling this API. I've hosted that on ngrok and utilizing that chat endpoint and calling that in on query to get our response. So this API returns our audio bytes directly. So that is why I'm just passing this background response uint8 list, and that brings us to our third and fourth function that I added in this plugin, and that is on background response. Basically, this plugin works in background because obviously every time our app won't be in the background open. So commands like calling the Siri and playing the audio and using the AI workflow everything will work in the background as well. So that's good. Now let's go ahead and move over to our background response. Basically, we check if on success is null or not. If it is not null, we just call that function, which is getting passed from the Dart inside the init state that we are initializing. But if it is null, then inside the plugin itself, we are utilizing the Swift native text to speech and utilizing that so that we can just say the message out loud to the user if we have the on success as null. Perfect. And if it is uint8 list, then if it is not null, then we are not doing anything. But if it is null, then we are not doing anything. And if it is not null, then we are simply calling the same on success method. But this time we will pass our uint8 list, that is the bytes of the audio that we want to speak. Right. So that's pretty much the Dart code that I wanted to show here. As you can see that we have our method channel implementation over here, and we have our interface, the abstract class written over here. So the abstract class basically just shows us what methods that we have, for example, the stream, background response, that we need inside our method channel because we are implementing our interface over here. So as you can see, we have our method channel implementation over here. We are having the method channel for Smart Siri and for our Smart Siri links. Basically, the links channel is used to stream out all of the messages that we will be getting and called by after calling our app intents. So whenever we say, hey Sam, then it starts throwing in the message, whatever message. For example, I ask, what's your birth date? Then that what's your birth date text as a message I'll be receiving from the stream from the Swift back to my Dart, so I can run it through our AI workflow and then return it back, right? So that is the stream, and this is the event channel that we are using because it is a stream. And another one is the background response, so that we can just speak out loud and use the native TTS in Swift and actually get our speech ready in Swift, right? Perfect. So these are all the Dart files that we are looking for. As we've talked about that this code does require background mode, so we will need that. So inside our iOS folder, first of all, inside our example project, I mean, we do need to add few permissions inside info.plist file, but we'll talk about that. First of all, let's cover up our plugins iOS folder and what additional classes I added here. That is our main plugin class, right? And let's talk about our, first of all, this podspec file. Podspec file basically helps us to initialize our plugin so that it can be utilized inside the Swift code of our example project, right? So here I've specified the minimum platform that this plugin requires, that is 16, because we are utilizing the app intents, and app intents in Swift requires the minimum version of iOS 16 based on the documentation. So that is what we are utilizing. And if we had to import any other libraries, our native Swift packages or libraries, we would be able to do that by adding those dependencies right over here. But since we are not using, so I haven't added any. And let's go to our plugin and let's see how the Swift code basically works. Right, so we are only importing our basic libraries, that is Flutter and UIKit. And here you can see that this is the notifier. So this is going to be utilized inside our plugin to stream back all of the response to our Dart stream and listen. And this is the AV speech synthesizer for our TTS. So we are going to change our text to speech so that whatever responses that we are getting, we should be ideally able to speak it out loud, right? Another, we have function that is extend app lifetime. What it is doing is it is initializing our background task here. So as I said, we need to add the capability inside our info.plist file. Also I'll show, but inside Xcode we need to add capabilities for background task and background mode. And here, as you can see, I am just initializing that here inside our extend app lifetime function. We have a function for configure audio session. So these functions are getting called in directly from our app intent that I'll show inside our example, right? But these are the functions. First of all, we establish our app lifetime to be able to use in background too. Then secondly, we configure our audio session. So we configure our AV audio session and we set the playback and the options right over here. Then this is the main register method that is getting called by Flutter. So here we have our method channel and our event channel setup that we are going to listen for. Our event channel has a stream handler, that is the notifier function, notifier stream handler that we are utilizing, and we are using this notifier and added this inside our set stream handler to get all of our streams that we are getting the messages, right? We are directly pushing our messages to this stream from our app intents. I'll show that too. But this is basically it. Inside our register method, we are initializing our method channel and our event channel and setting that Flutter and Swift communication here. Okay, so we have this handle method next, and this is getting called by the Flutter. So we are getting our method call and we are getting the method what we are passing, and we are basically using a switch case here. So we only have one method, that is background response, and we have this function for the handle background response which utilizes the AV speech synthesis voice, and using the native text to speech, we just use that and call the speak utterance, and we just pass in our message over here. Basic Swift code to implement the text to speech. Perfect. And below we have our selection push only stream handler, which basically is utilized to initialize our notifier over here. And here you can see I've implemented the push and flush functions on listen, so basic functions over here for our Flutter stream handler, right, which is going to be utilized in to pass on all of the message from Swift to Dart. So we've talked about our plugin. It's not like very complicated. It's quite basic plugin here. And let's go back to our example folder. And first of all, let's talk about what all changes we need to do here, right? Because inside our iOS folder, we need to make a few changes. First of all, inside our pod file, we need to specify our platform. As I mentioned that the plugin, the app intent only support iOS 16 and above. So we need to specify that in our pod file over here. Other than that, inside in the bottom, we need to specify and add this code as well. That is, we are specifying the deployment target for every configuration. I think, I'm not sure, to iOS 16. So I've added that too. And the main code lies inside our runner here. So first of all, we have our, so I added I think 2 additional files, that is app shortcuts and our main chat intent, right? But before that, let's go to our info.plist and let's scroll to the bottom. And this is the extra permissions that we have added. First of all, we need the microphone permission. We will need the Siri usage access, so I added that. We need the speech recognition, have added that too. And at last, we need the background mode as well and utilize the audio. So this will add the capability in the Xcode for us. So we should be able to use the app in background and play audios as well in the background, right? So that is it, the change that we have to do inside our info.plist file in our example project, right? And we have added our app shortcuts and our chat intent that we'll talk about in a minute. But let's go to our app delegate file. And as you can see, nothing has changed. Everything looks primarily the similar app delegate file that we get from a scratch project, right? So these two files that I was talking about, first of all, is the app shortcuts.dart. What this means is we need to make our app shortcut provider. Why? Because as I'll show you inside our simulator too, once we run our example project, what it does is inside shortcuts, it automatically adds the app shortcuts that we initialize. So here we are initializing one app shortcut, that is our chat intent. So that is what, if I go over here, let me bring this up over here. You can see that we have this Sam app and we have this Hey Sam shortcut added over here. Why and how this Hey Sam text appears, that is coming in here. You can see that Hey Sam text appears from the phrases and it picks up basically the first phrase, whatever phrase we are taking in, right? So as you can see that this application name is important, because the trick is that iOS does not allow developers to change the wake word, right? So their wake word is fixed, that is Hey Siri, and we cannot change that. But what we can do is we can play around and add our application name inside this phrase itself. Because one quick note, that whenever you are specifying the phrases, make sure that the application name is added inside the phrase, otherwise it won't work. So that is a limitation that iOS adds in. But to make our workflow, because we need similar to Hey Siri, we need to implement Hey Sam, right? So to implement that, we need to change our application name to Sam or whatever name of the agent you want. So to change our application name, you can simply go to info.plist, scroll up, and you will find this CF bundle display name and just change that to whatever name you want. What this will do is it will change the name of your application first of all. So if you go back, you can see that the name is changed to Sam, right? And this is going to be helpful in our shortcuts, because now we can use phrases like Hey Sam to kick in our workflow that we wanted, because it adds the shortcut for us, because Hey Sam shortcut is now added. So we can just ask Siri as Hey Sam, and it is going to trigger this particular shortcut, which will trigger our workflow, whatever workflow that we have. Right, so I added 2-3 phrases over here, and we are returning one shortcut, that is our start intent. Again, app shortcut requires iOS 16 and above, so we are specifying that. Right, and over here inside the chart intent, we are basically inside our main perform function, we are utilizing configuring our audio session, and we are extending the app lifetime so that once we run it for the first time, it will initialize the app lifetime, and it will initialize that the app can run in background, right? And then whenever whatever message or task we get from our app intent, we are pushing that to our notifier so that it further pushes it back to our Dart, and we can handle and return a response accordingly, right? So it requires a parameter task, and the request value dialog, basically, hey, how can I help you, is what agent asks us to do, as you saw in the demo as well. So that is the chat intent that we've added over here, and that's pretty much it. Like, this perform function is the main one, and that is where we are getting the task, that is where we are getting what user wants, and we are pushing that to our Dart back using our smart Siri plugin, right? Let's go back to our main.dart, and whatever task that we were streaming it, we are going to get it in our on query, and this is where we are going to get our task, and we are going to simply we should ideally pass the task like this, right? But otherwise we can just pass any text as well, and that should work. And we are going to return our audio byte, so I just added this background response unit 8 list so we can play our audio inside on success method. Perfect. So that's pretty much it, how the entire plugin works. So that's a wrap. I hope you learned something new in this video. Subscribe to my channel to learn more about Flutter, app development, AI, agentic applications, because that's where the future is going to be. Check out this video if you want to see me build Netflix, Uber, YouTube, and Pinterest splash screen animation completely from scratch in Flutter. Or check out this video because you do things that you'll probably like it. I'll wait. I'm kidding. So, I'm Yash Markan. See you next time.